Hello, everyone, and welcome to our webinar today, Easily Build Data Secure Applications with Postgres. We are about to get started. We got a full plate here, but before we do, just a couple of quick housekeeping items. First of all, the webinar is being recorded, and you will be receiving a link to the recording later in your inbox. Also, we expect a very interactive webinar today. You feel free to ask questions at any time during the webinar using the little questions button in the bottom right corner, and we will be answering all the questions at the end after all our speakers are done speaking. There will also be some polls that you will see pop up while we're going through the webinar. Please take the time to answer those polls, and you will see some of the results as well. With that, let's get going. I would like to turn things over to our host today, Sushant Rao. Sushant, all yours.
Great. Thank you so much, Hormaz. So, hi, folks. I'll be your host for today, but let's start with the speakers. Our first speaker is John. John, would you mind introducing yourself?
Thank you, Sushant. Hello, everyone. Welcome. My name is John Turdiev. I am a senior solutions architect here at AWS. I joined the company about a year and a half ago. I have 20 years of experience in software development and solution architecture. At AWS, I work with our cybersecurity startup ISVs to help them build cloud-optimized solutions.
Great. Thanks for joining us, John. And I got to admit that I can actually recognize your background. I'm kind of a SFA nerd, and I actually recognize I think I know where that spot is that John took the picture. And then we're pleased to have our second speaker, Billy. Billy, would you mind introducing yourself today?
Great, thanks. Yeah, I'm Billy Van Cannon, Director of Product Management at Baffle. I've been here about 2 years, but I've been in cybersecurity for like 16 years. And before that, I was an RF hardware engineer, so I made radios. And I'm coming to you from Chicago today.
Awesome. And I hate to say it, Billy, but I actually recognize the background in your picture as well. So, folks, let's talk a little bit about what we're going to cover today. It's a pretty straightforward agenda, but there's a lot of material to cover in this to give you kind of full context. So we'll start off with talking about Postgres as your database engine, why you want to consider Postgres. Then we'll talk about Amazon RDS and Aurora as your managed Postgres service in the cloud. Lastly, we'll talk about transparent application level encryption for data security, right? There's additional threat vectors when you move to the cloud, and with the shared responsibility model, you are responsible for, kind of data security. So we'll talk about that. But let's start off with John with Postgres as your database engine. John?
All right, thank you. Right. The cost of compute and storage has come down dramatically over the past decade, resulting in companies having access to more data than ever. However, to be able to take advantage of this information, it's important to have a modern data architecture to be able to innovate with the data and maintain optimal performance, scale, and availability. To modernize, many of our customers moved away from monolithic database architectures to microservice architectures, and they are running their application at a massive scale. With a microservice architecture, customers are using a variety of databases that are purpose-built, matching each workload to the right database to support the demands of their application. A number of factors are contributing to the data requirements of modern apps, such as number of users, data volume, locality, access pattern, and so on. Before we continue, we would like to ask the audience which open source relational databases you are currently using. You should see a poll open up on your screen if you would provide your answers there. The options here are MySQL, PostgreSQL, MariaDB, and other. So for the last option, please feel free to specify your database in the comments section. So let's give it a few seconds for folks to answer their questions. All right, so far we have PostgreSQL winning by a large margin, followed by MySQL at 25%. Oh, okay. So A developer survey conducted by Stack Overflow shows that PostgreSQL has become the most popular DB technology in 2022. For the first time, about 46% of respondents chose PostgreSQL, and 45% chose MySQL in the popularity rankings for the professional developer community. And the same survey conducted in 2023, PostgreSQL share has increased to 49%, while MySQL dropped to 40%. PostgreSQL has emerged as the preferred open source relational database for enterprises and startups alike to power a wide range of critical business and mobile applications. It has earned a strong reputation for its rich feature set, including reliability, performance, scalability, extensibility, security, and of course, a dedication of its active community. PostgreSQL also has powerful add-ons such as the popular PostGIS, PG Audit, PG Vector, HStore, and many others. Earlier, we talked about the importance of having a modern data architecture to be able to innovate with the data. So, how do you build a modern data strategy? A modern data strategy starts with moving towards an infrastructure that enables you to achieve the scale you need at the right cost while reducing operational burden. And migrating to the cloud offers these characteristics. Since the beginning of Amazon.com, we have run some of the world's largest and busiest production relational databases. So we do understand how expensive and complex it can be to manage database administrative functions. Adapting these operations to the cloud also requires new skills and training. This is why we created managed database services. By migrating to managed database services, there are three overarching benefits you can achieve. The first key benefit is that managed databases increase the efficiency of your database by automating undifferentiated administrative tasks and removing human error. Second, by improving the efficiency of your databases, you're able to reduce costs. For example, when it comes to scaling your databases, if you have spiky workloads, instead of constantly over provisioning your database for the peak capacity, customers can use Amazon Aurora Serverless for instant scaling in fine-grained increments, resulting in cost reduction and improved performance. This is one of the many examples of how managed Amazon RDS and Aurora help reduce costs and increase efficiency. And finally, with RDS focusing on automating undifferentiated tasks, you are at the same time freeing up your resources, team resources that you can redirect to focus on innovating on behalf of your customers. To illustrate the burden of managing databases, we can look more closely at the various database administration tasks required to keep a database up and running. So RDS removes the burden by managing a number of these tasks, including automatic failover, backup and recovery, database upgrades, and routine maintenance, to name just a few, leaving you only with the tasks that matter the most to your application. So these are schema design, query construction, and query optimization. From early days of our learnings operating infrastructure for Amazon.com, we realized that while traditional relational databases were a valuable tool, there were a number of use cases where they fell short. Scaling challenges of traditional old guard relational databases draw us to create new relational databases reimagined for the cloud. So the ability to use the database engines we knew with the benefits of cloud like elasticity, durability, and availability was a massive leap forward at the time. For workloads where a tabular data model would be ineffective, we created Amazon DynamoDB, which is our NoSQL database. And over time, we continued to find use cases where there were unmet needs at the intersection of data types, access patterns, and of course, developer preferences. So we continue to create additional non-relational databases to ensure customers were always able to use the right tools for the right job. So today, AWS customers have the choice of a number of non-relational database services, including Elasticache, DocumentDB, Neptune, TimeStream, and so on. Amazon Relational Database Service, or Amazon RDS for short, including Amazon Aurora, is our collection of managed services that makes it simple to set up and operate scalable databases in the cloud with just a few clicks. Launched back in 2009, customers benefit from over a decade of proven operational expertise, security best practices, and innovation for cloud-native databases. So, as a managed database, Amazon RDS helps to remove inefficient and time-consuming database administration tasks without needing to provision infrastructure or maintain software. Amazon RDS allows customers to deploy relational database management systems with the engine and deployment environment of their choice. This means when moving to a managed database, they can quickly begin taking advantage of all the benefits that managed databases offer, such as improved performance, availability, scalability, and security. So with RDS, customers have the choice to deploy on any of 7 managed databases you can see on your screen. And for customers that have additional requirements that need capabilities outside of fully deploying on the cloud, we offer 2 additional options. So this is with Amazon RDS Custom for customers who are able to deploy managed database for applications that require additional customization for the underlying operating system and the database environment itself. And another option is for customers who need a hybrid relational database management solution, we offer Amazon RDS on AWS Outposts, where you can deploy fully managed database instances in your on-premises environment. And Amazon Aurora is a relational database service that combines the speed and availability of high-end commercial databases with the simplicity and cost effectiveness of open source databases. Aurora is fully compatible with MySQL and Postgres. It also, as a fully managed service, automates time-consuming administration tasks like hardware provisioning, database setup, patching, backups, while at the same time providing all the benefits of commercial-grade databases at the fraction of a cost. RDS also offers 3 fully managed open source database offerings. So these are RDS for PostgreSQL, RDS for MySQL, and RDS for MariaDB. Amazon RDS open source database provide you the same benefits as an open source database while simplifying database management, enabling you to quickly start building brand new applications or migrating existing ones. And while doing that, customers are able to leverage the familiar code, features, tools, and in the case of PostgreSQL, extensions that they use today. And RDS consistently keeps up to date with the major and minor version upgrades from the open source community. So you can benefit from the open source innovations at the same time with combining with the AWS innovations in a single service. Amazon RDS is cost effective. We discussed some of the benefits earlier, but another benefit is for organizations who are seeking to break free from costly licensing fees, they can migrate to RDS and start benefiting from all the innovations of open source engines. Amazon RDS open source database also offers a broad selections of high availability and durability features, such as multi-AZDB clusters. And with this option, customers are able to improve their write transaction latency, reduce failover to typically under like 35 seconds, and also increase read capacity. And finally, Amazon RDS open source is also very flexible. When you have homogeneous migration, you can easily lift and shift your existing open source databases to AWS using tools like AWS Database Migration Services, or DMS for short. And for heterogeneous migrations, the AWS schema conversion tool can help convert the schema of your database to a format compatible with your chosen open source database.
So John, quick question for you. Which database versions does Amazon RDS for Postgres support?
Okay. At the moment, the major versions supported are 11 through 16. In fact, I would encourage the audience to check the PostgreSQL documentation on our website for up-to-date information. And also over there, we have calendar that outlines all the release schedules, and more importantly, also the end of life support, so you can plan accordingly. Okay. Now, I would like to quickly want to touch upon a few of our most recent innovations, specifically for RDS open source engines. Trusted language extensions for PostgreSQL provides security agility for developers decoupling third-party development from RDS certifications. With TLE, as soon as a developer determines an existing extension that meets their needs, or is ready to implement a custom extension, they can safely deploy it in production. So meaning that you no longer need to wait for AWS to certify an extension to begin implementation, because TLE is considered to be part of your application. In the past, making updates to databases like major version upgrades or schema modifications required significant time and resource to execute to minimize downtime. We introduced blue-green deployments. With this feature, in just a few clicks, you can create managed staging environment or green environment to safely test database changes without affecting your production databases. Your green environment stays up to date with your production or blue environment using logical replication. And when you are ready to promote your changes into production, the process is very simple and takes as fast as a minute. Amazon RDS optimized writes feature achieves performance gains by simplifying our implementation of atomic writes for RDS for MySQL. With this feature, customers can now gain up to 2x improvement in write transaction throughput without incurring additional cost, at the same time maintaining data durability. And last but not least, optimized reads benefit complex queries that utilize temporary tables, such as queries involving sorts or hash aggregations or high-load joins and so on. Whenever you have a complex query, instead of placing the temporary tables on Amazon Elastic Block Store, Optimized Reads places your temporary objects directly on your database instances NVMe instance store to process your queries up to 50% faster than before. Now that we have reviewed different features and benefits of managed databases, let's see where the attendees are hosting their relational databases today. So the options here are on-premises, Amazon RDS or Aurora, or AWS self-managed, such as EC2 instances, or other public clouds. Again, feel free to specify your other hosting options in the chat section. Okay, looks like the majority of people are choosing on premises. Oh, we have a tie with RDS. Okay, RDS and Aurora appear to be the top choice, right? Hopefully, some of the benefits of you know data modernization techniques, including moving to managed services, was a good information, and you also can start leveraging some of the benefits that we enumerated earlier. All right. So now let's talk about the security of Amazon RDS. Security is a top priority here at AWS. We work with our partners like Baffle, who offer additional layers of security solutions. Together, we provide services, tools, guidance, and support to help you achieve your security and compliance goals in the cloud. I will briefly mention some of our built-in security mechanisms for RDS, and then pass it on to Billy to explain Baffle's application level encryption solution. Security is a shared responsibility between AWS and you. There are two concepts, so security off the cloud, which AWS is responsible for, and security in the cloud, which is customer's responsibility. What this means is AWS is responsible for protecting the infrastructure that runs AWS services that you use in the cloud. AWS is also provides you with services that you can use securely, and we have AWS compliance programs that enable our auditors to regularly test and verify the effectiveness of our security mechanisms in place. And your responsibility here is determined by which AWS service you are using. You are also responsible for other factors such as sensitivity of your data, your organizational requirements, and applicable laws and regulations. So in the context of RDS, your job is to leverage the security and compliance mechanisms we provide as required by your business objectives. You don't have to configure security access for processes that Amazon RDS manages. Here are some of the layered mechanisms to manage access to your Amazon RDS resources. RDS makes it easy to control network access to your database, allowing you to run your database instances in Amazon Virtual Private Cloud, or VPC, that enables you to isolate your database instances and control access via security groups, network access controls, control lists, and so on. And you use AWS Identity and Access Management to assign permissions that determine who is allowed to manage Amazon RDS resources. RDS also supports multiple authentication methods, including Active Directory and Kerberos. RDS also offers a wide range of compliance readiness programs, including HIPAA eligibility, and we offer a wide range of observability tools, such as VPC flow logs, CloudWatch logs, and CloudTrail that captures all the API calls made to change your RDS resources. With that, I now turn to Billy to continue your discussion with application level encryption and why you need it.
All right, thanks a lot, John. I hope everybody can see my screen. So I want to stay on the AWS shared data model here. And right on top, you can see you are responsible for protecting your data. Now, of course, AWS has to take this stance from a legal perspective. If you, for example, leave an S3 bucket wide open on the internet with sensitive data, what can they do? However, like John said, they're doing everything they can to provide tools needed to protect your data. They have numerous ways to lock down your S3 bucket in that example. But that's also why they're partnering with people like Baffle. So a little lower on the chart, you can see that they have client-side encryption and server-side encryption, again, on the customer side. And when I set up an RDS instance, I notice, and I copied down the screen there at the bottom, says enable encryption. So when you're setting up an RDS instance, that's turned on by default. And you might think, okay, well, as long as I don't turn that off, it's taken care of. But I would actually argue that this is AWS doing their job protecting the physical hard drives, the physical storage. And we're going to dive into that distinction a little bit. But first, let's have a poll. All right, so basically, I want to get a little bit of background from the audience here. So what security and privacy frameworks concern you? So I've got NIST on here, ISO 27000, PCI DSS, HIPAA, GDPR, CCPA, and other. If it's other, maybe if you could specify, that'd be great. But, and you can choose more than one. So I'd like to kind of get an idea of what people are concerned about these days. All right, it looks like we have a pretty good spread. NIST and PCI coming in at 20-some%, and then GDPR and ISO in the teens, other at 11%, HIPAA. So it's pretty big spread across a lot of different security and privacy frameworks. Okay, great. So I thank you for that poll. And so coming back to this idea of why this encryption that AWS has enabled is more them protecting the infrastructure than the actual data. All right, so if we look at a database and we try to break it down into its components, first is the database software. So this is, if we're talking Postgres, the actual Postgres software. And then it's going to be sitting on top of an operating system. So whether it's Linux or Windows or the AWS hypervisor, which is parsing out the hardware, or the physical storage there. There's a hard drive there, but it could be tape drives, SSD, whatever the case may be. If you encrypt with the database software, it's called database encryption, and it's also called transparent database encryption, which we'll see why in a second. If it's encrypted by the operating system or the hypervisors, then it's called disk encryption, and that's what AWS is implementing. And it turns out that from a user perspective, it doesn't matter what level the encryption is being done. The user, when they use the database, their data that's written to the physical storage is encrypted on the way there and decrypted on the way out, and the user is none the wiser. However, and that's great, but from an attack vector perspective, this was invented, several years ago when most people's databases were, in their basement or in a broom closet somewhere, and physical theft of the data was, of the hard drives was a concern. However, today, the bigger concern is remote access. Is somebody stealing credentials from the DBA or from a user and getting access that way? I mean, AWS has like the security guards and cameras and the small windows and the whole 9 yards. So we really aren't worried about the physical theft anymore. We're worried about the remote access. And it turns out that you don't have to take my word for it. When I was asking about what security frameworks you guys are concerned about, PCI I'm going to pick on because it's the most prescriptive one. Most of them just say, like figure out what your assets are, including your data, and then rank them by sensitivity and apply access controls according to that sensitivity. And they kind of leave it at that. But PCI is very specific. They're like, we care about credit cards, almost don't care about anything else. It's credit cards, and this is how you are going to implement access controls. And here's the parameters around it. And then they have, if you're a large enough retailer, they have a QSA or an auditor come check that. But so one of the PCI requirements is that you will encrypt PAN, which is personal access numbers or credit card numbers. Primary account numbers or credit card numbers. You will encrypt them even in your production environment. And so in this specific one, 3.5.1.2 here, it says if you're using disk level encryption, and we'll skip past the parentheses there, to render your credit card unreadable, it is implemented only as follows. On removable electronic media, so your hard drive, your laptops, your phones, your thumb drives that can be stolen physically, that makes sense. But they say if you're using it for non-removable media, like your database, you have to encrypt your credit card numbers with some other mechanism. And and then I'll go back to in parentheses there, they say, well, database encryption's okay. And so what's going on here is PCI, they were created in 2006 and they were concerned about physical security. So they said you got to encrypt the hard drives. But then now they're seeing like, okay, yeah, the remote access problem is the bigger thing. So they're slowly moving that way. So with PCI DSS version 4, they're kind of putting a finer point on it. And my theory is in the future, they'll say, look, database encryption doesn't work either. And why they're picking on one and not the other, I have some conspiracy theories that probably aren't appropriate to share. But the biggest thing is they're just trying to move people over and they're migrating. They said for the last 18 years, this was acceptable. So now we're going to try preparing people to move away from that. But it turns out even if your QSA allows you to do database or field level encryption, you still need to meet these other requirements. So all security and privacy frameworks have this concept called least privilege. And what that means is you only share sensitive information with people who need to know it for their jobs, and that's it. And there's a couple specific ones I picked out of PCI here. Basically, they're saying if you show somebody a credit card number, show them a masked version. The BIN is the first 6 digits of a 16-digit number, and the last 4 digits, you can show them unless they have a legitimate business need to see more. Heck, they even have to have a legitimate business need to see that much. But if you want to show them the whole credit card, that has to be outlined. And then remote access technology. So if somebody's remoting in from their home and they want to get access to the data, maybe they can get access to the other data, but when it comes to credit cards, don't show it to them unless they have a legitimate need and it's well documented in the whole 9 yards. So like even if you have database or disk encryption, you still have to have these additional mechanisms beyond that. Let's see here. One of the things that also comes up on here, and I probably have to put my disclaimer in. I'm not a QSA. That would be between you and whoever your QSA is on whether you're compliant or not. But one thing you will probably never get dinged on is if your database admin has access to the data. I would actually contend that even your database admin shouldn't have access to the data. And we'll show how you can do that with Baffle here in a minute. All right, so this is getting into Baffle. And this is the most obvious drawing ever. But basically, you're starting out with your database, and you have an application attached to it. And you're reading and writing data to that database in the clear. Now, what I really want to get out of this slide is to say that it doesn't matter if you're writing that application right now, or if it's a legacy application that was written years ago and you don't even know who wrote it anymore, or if it's a third-party application where you have no control over the code whatsoever, if that application can talk using SQL to your database, Baffle will work. All right, so how do we do that? Baffle is a reverse proxy placed between your applications and your database, and it operates at the SQL level, essentially encrypting on write and decrypting, masking, or denying access on read. Okay, because it operates at the SQL session layer, no code changes are required. So this makes Baffle the easiest way to implement encryption for all your applications. Baffle also manages the keys for you. So if you were doing encryption in the application, not only would you need to change code to do that, but now you have to write code to manage your keys. And that also means that every application is separate, so you now have to set up some other system to manage them centrally, which is also a key security concept. Baffle uses a two-tiered key method, so there's the data encryption keys and then the key encryption keys. It's set up such that Baffle software never has access to that key encryption key. And if you remove access to that key encryption key, then the software can no longer access the data and decrypt it for people. So you're effectively shredding it, which is a key thing we'll talk about in a little bit. Baffle software that you can deploy, so it's not a SaaS. You can completely control where and how it's implemented. And it's along with that, it's packaged in Docker containers, so you can scale it vertically or horizontally, however your situation requires. Over here, we have Baffle Manager, and that's the GUI and API, which you can use to manage, configure, and audit your Baffle Shield deployments. Okay, so in this picture, I only have one application attached, but you can also apply several applications and apply something called dynamic masking. So this is essentially the same picture. Now we have this in encrypted database connected to Baffle, and I'm showing the database admin connected directly to the database so that they can do their regular tasks, okay? And then all these different applications, the view that they can get is determined by their roles and the masking. So I'll go ahead and actually even dive into a demo here. So I'll kind of switch back and forth here. So the first perspective I want to take is the database admins. And so I'll go over to that connection. And the first thing I want to do is pull up the users that are created. So I'm the Postgres, so it's the default admin. But look, notice we also have the RDS managers and admin. So, of course, I work with AWS. I trust them. But them having access, or at least their services having access, is not least privilege, at least to the letter. And also, if I'm the DBA, me having access is not least privilege, like I said. So as a DBA, I went ahead and created these other users. But if I want to access the data, it comes encrypted. I've encrypted the credit card numbers and the social security numbers. So now your DBA can do their job without having to worry about that. And that's should be a big relief for most DBAs. Like really they don't want to have access to the financials before the CFO or the employee social security numbers or their customers' credit card numbers. It's much better if they can just do their job and not worry about that. Okay, and then so if we look over here on this human resources, I got Harry set up for human resources, and I wanted to say the credit card number is completely masked with confidential, but human resources need to see the social security number because they need to set up our benefits. So we'll go to that, and we'll do a select. And there you go. So when I select as a human resources application, I can see confidential social security number or credit card numbers, and the social security numbers show up. And then if I want to do support for them, the only reason they need to see the numbers at all is they need the last four for customer verification. So we'll go ahead and pull that one up. We got Sally from support here, and we'll pull their data. One thing too on this one is for this application, if you put X's in there, it's a wrong data type, so it messes up the application. So what I did was set it up so we can set random numbers in there instead. So let's see here. So let's go to support. Did I do it? Yeah. So the first ones are blocked out with X's. They can access the last four. And then the social security numbers, the last four digits are right, but I've randomly put in digits for the other ones. And so if I access it again, they change. But that's so that the application doesn't get messed up by seeing X's on there. And then if I'm a remote user, we've decided they don't get to see anything. So they're completely masked. So we'll run over here to Richard from the remote user, and we'll pull their data down. And you can see everything is completely masked. So that's dynamic data masking. Okay, and then another use case is static masking for lower environments. So let's say this isn't PCS because you're not encrypted in the card data environment or in the trusted production environment. But let's say you're completely compliant with some other standard. You're happy as you can be. It's you got access controls all over the place on this, and you're compliant and secure. And then somebody comes along and says, you know what? I'm a developer, or I'm from QA and I need to do testing, or I'm a DevOps engineer and I have a whole different environment set up, and I need data, and I don't want to create my own. And probably the better excuse they use is, I want data that looks like production. So what do? They socially engineer somebody in production, and I say that it's not social engineering, meaning not like in a malicious way. They just go talk to somebody they know and say, hey, let me get information. And so whoever it is says, okay. So they copy that data in there, and the next thing you know, your sensitive data could be anywhere. Who knows how many multiple copies they could make? Who knows how many applications are connecting to it? And so this is a bad situation because you have this whole, reproduced environment. They're also called pre-production environment, but lower environment that is completely out of compliance. I actually have a friend in Chicago who works for a large healthcare payments company, and he started out as a security officer, compliance officer, and his engineers were doing this, and he told them to stop it, and they wouldn't stop it. They pretty much ignored him, so he actually shut down their database. And it's a huge company, so it went clear up to their SVP, and the SVP called up his equivalent over above my friend. His name's Mick. And that guy called him into his office and he said, Mick, they want to fire you. And Mick's like, well, I mean, I guess that's up to you, but if you fire me, you're going to have to replace me with 3 people, because not only do you need to replace what you wanted me to do on the trusted environment, but now you got to find 2 other people who are going to go track down the, 3 dev environments that are set up, the 4 test environments, the DevOps environments, and you got to get all that under control. And that, I think it was a CISO said, you know what, that's a good point. And, a couple of years later, my buddy Mick is now a VP at that company. So, hopefully that's inspiring, but if you try this and get fired, you can't hold me responsible. Anyway, how can we help both, the compliance officers and the engineers? So what we can do is we can use AWS DMS, which John mentioned is, just for moving data. You can use any data mover. Put Baffle in between there. And here we're encrypting the credit card numbers with something called format precision encryption, which just means it's it's a strong encryption according to NIST, but it makes your encrypted data look like your original data. And Baffle can even refine it further, so it passes something called the loon check, right? So we go ahead and copy that into pre-production, and as long as we keep the keys over here and safe, this data is now, we're calling it masked even though it's encrypted, but basically that data is now shredded as far as in that environment, and no matter who connects to it, they can only receive the data in there. So that's why we're calling it static masking, okay? And then because we used FPE, this application, when it runs that loon check, it's fine, it doesn't hurt anything. And then the social security number, we use traditional encryption, because even if that app is reading it, it's not doing anything with it, so it doesn't mess anything up. And they can do all their testing and continue on, and everybody's still secure, and everybody can do their testing. All right, so now we're gonna kind of take a little bit of a shifting gears here. And we're going to talk about multi-tenant applications, or SaaS. SaaS is kind of, most of the time is by definition multi-tenant. And the appeal of this is the fact that you can have many customers share the same infrastructure, which provides scale and lowers the cost per customer. However, if the customers demand that they have their own software stack so that they can isolate their data, say they all demand their own database instance, then you lose your scale and a huge part of the reason you even offer a SaaS. So what can we do if the customers demanding that? How about we isolate it using encryption? So in this situation, here at the bottom left, we have a multi-tenant application, or a SaaS application. We have it connected to Baffle, and in turn, Baffle is connected to a database with a table. And every row in a table is assigned to a different tenant. Now you can have multiple rows. Here I only have 1-to-1, but you can have multiple rows. And whenever that row is accessed, either written or write, read or write to it, Baffle will go ahead and reach out to that tenant's key store, both the DEK and KE key store, get that key, and then provide the encryption or decryption needed. So now if this table is stolen, nobody has access to those keys, let alone each other's information. Baffle allows every tenant to provide their own key. So here I have AWS KMS, HashiCorp Vault, Azure Key Vault, but also not shown. You can do GCP, you can do IBM. And the basic idea, right, is every tenant can bring their own key, protect their own data. And then at the end, let's say they want to end their relationship, all they'd have to do is revoke access, and that data is as good as shredded. They don't have to do an audit to ensure that you deleted that data. Baffle has a customer that has several large banks, and the banks demanded that they be able to provide their own key and encrypt their own data. And on their website, that's a huge selling point. Like, if our relationship ever goes sour, remove the key, it's the data's destroyed. Not only that, if the FBI calls and says, the SaaS provider, and says, give me this data, the customer could revoke the key and shred that data. So for some people that may seem like a stretch, but I know for a lot of international companies, that's a big concern. So along those lines, you can also do the same thing with logical databases. So now we have one database instance of Postgres, one server, but you can within that have multiple logical databases and provide, bring your own key for each of your tenants per each database. So now everything in that database is encrypted, that you choose to encrypt is per that key. All right. So now I'm going to go into something called privacy enhanced computation. At Baffle, we call it real queryable encryption. And if you don't know what those are, you're probably still wondering what the heck I'm talking about. So here we have data, having names, ages, salaries, and ID of people, and we decide that we want to encrypt the name and age and salary of all those. And so if Baffle stopped here, you could still do what most encryption solutions offer is direct match, right? So if you say select salary from this table for Elise, where name equals Elise, you can pull that salary. However, let's say you have a data analyst and she wants to do her job and do a more comprehensive study of something, and she wants to do any kind of sort, search, mathematical operations, or indexing. So here we're saying she wants to sort by salary and then do some math on those things. This is privacy enhanced encryption, or real queryable encryption. So if Baffle stopped here, what would happen is, when that happened, the database would go look at the salary here and say, I don't know what this is more or less than 100. It looks like random garbage. So it would just provide an error back. So what Baffle did previously is we defined some UDFs and we wrote them in C++ and put them on Postgres. And I'll show you how that works in a second. But in managed databases, in AWS RDS and Aurora, they didn't allow user-defined functions on there. So we were kind of stuck if somebody wanted to have a managed database. And then, like John talked about, they recently added trusted language extensions, and both for RDS and Aurora. And so Baffle now is implementing their user-defined functions in Rust. There's several different languages, but Rust being the high performance, I mean, it runs almost as fast as our C++, or maybe even as fast. And it additionally has memory protection. So those are two key objectives for Baffle. So that's why we went with Rust. It enables these server-side operations, or privacy-enhanced computation. Baffle's the only software-based and performance solution available. Other cloud providers don't provide TLE. So now if we look at this, basically what happens is when this query goes through, Baffle Shield recognizes that, and it breaks this down into smaller functions that is forwarded onto the UDF. The UDF will then pull that data, decrypt it, perform the functions, and send the answers back while keeping the data encrypted in the database itself. And then you have the responses, and it's still protected. I will say the one attack vector that is left is if somebody can get access to the database and dump the memory, then maybe they can get at it. But that should be operationally protected. There's pretty rare cases where you're going to allow somebody to do the memory dump. Plus, it being in Rust also helps with that significantly. So privacy enhanced computation where you can do operations on encrypted data and still keep it protected. And let's see here, I'll do a little demo on that one also. All right, so I'll switch over here. Okay, so this first one, sorry, again, you can't see this, but the first one is a direct connection to the database. So when I pull it, I've got quite a bit of data here, but the name is encrypted and the credit card number is encrypted, the items and the quantity here is encrypted, right? So if I try to do a transaction, like just a simple one, like any of them where that transaction quantity is over 2. So the transaction quantity is this guy, right? It's not going to make any sense, and you get an error. All right, so now we're going to connect through Shield, and we gave this person, full access to everything. So now, when we look at it, everything comes back decrypted, but it's still encrypted on the database. So now when I do that same transaction, just bring back all the ones over 2. So right there's a, whoops. There was a 2, but now it's all the transactions that are 2 or above, okay? And then I can even do things like now, let's do a sum of all the transactions, okay? So there's the number. And then if I do a sort first, like everything over 2, and some of those obviously should be a less number because we're filtering some out, 9,000. So you can do this analysis on encrypted data. Okay, and I think Hormaz, turn it over to you. All right, Hormaz, were you want to run the poll, or is it?
So the poll was basically to see if anyone would be interested, given what you've seen, would you like to try it? And you had a couple of choices. So go ahead and fill out the poll and see if any of these would be interesting to you. And then Billy, you got one more slide, is that right?
Yep. I'll give him a second here to answer the polls. All right, sounds like we got quite a few people that want to check it out. All right, so moving along here, kind of wrapping up. Transparent data encryption and full disk encryption, we kind of went over that. But some of the other options out there is PG crypto. So this is a module that Postgres provides where your application can send the data and specify what kind of encryption and also supply the key. So this is going to put a lot of burden on you having to write that code in your application. You're going to have to worry about key management, and it's also not going to do multi-tenant or SaaS. I mean, you could obviously write the applications yourself, but it doesn't come with that module. API is the way a lot of our competitors do it. We kind of look at that as a do-it-yourself because you now still have to rewrite your code to go reach out to that API instead of reaching out directly to the database. And then the multi-tenant and database operations, a lot of them don't provide. And of course, we believe Baffle provides all of these things. And with that, I'll turn it over to Sushant.
Sure. Thank you, Billy. So just to summarize, I think there are 4 key things that you should take away from this, right? One is no code implementation. It's the easiest way to encrypt data and manage keys. You don't have to change your applications. You don't have to worry about code, maintaining that code. So it's really easy. You can provide least privilege access to all user applications, including the DB and cloud admins. This is really important when you consider privacy regulations. Complying with those really does require you to provide access controls, and you're responsible for the security of your data, even on infrastructure you don't control, which is typically cloud. So you have to make sure that your data is protected. The third is we're the only performance software-based solution on the market for running queries on encrypted data while keeping it safe, right? This is really important. Regulations like GDPR are requiring companies to, due to data sovereignty, keep data separate, but that becomes problematic when you're trying to do analytics and trying to look at, for example, your global customer base and trying to run analytics on it. How are you going to do that? So with real queryable encryption, you're able to, basically encrypt the data by country, but the analysts can still run all their queries and get the result, even if they can't see the individual user's data. Lastly, AWS has implemented trusted language extensions in Rust, enabling Baffle solution on both RDS and Aurora. So they're the only company that has done this. So this is a real benefit to you. Billy, can you hit the next slide? I don't know. So next steps in QA, click again. Oh, I guess that for some reason disappeared. Oh, it's in the other one. So sorry, folks, let me just switch over to, here we go. So next steps in Q&A. So try Baffle for Amazon Aurora and RDS for yourself. You see the QR code. You could also see the URL. So if you have a mobile phone with you, pull it up. You can have it focus on the QR code. It will pull up to that, essentially that URL. What you'll be able to do is meet with a Baffle security expert. You'll be able to discuss your data security concerns. You'll be able to verify Baffle's capabilities meets your needs, that it can do what you expect it to do. And then lastly, you get access to Baffle. It's a pretty straightforward thing. Just want to make sure it works for you before you get access to it. So now I think we've got a couple minutes so we can hit questions. So I see that there's a couple questions here. John, I think this is a good one for you. How do trusted language extensions on Postgres relate to Postgres extensions? Are you able to talk about that?
Yeah, sure. So trusted language extensions for PostgreSQL, or TLE for short, is the official name for the open source development kit that's available on GitHub. It's called PGTLE extension. So in short, the TLE is actually a PostgreSQL extension. It's available for use on any PostgreSQL system. Two primary benefits are, one is around security. We talked about this briefly, but it basically gives you fine-grained control and also limits the negative impact if something goes wrong to the single database connection. And also it removes the constraint where extension would require a file access, which is typically not available in a managed services.
Awesome. Billy, it looks like you got a question here. How does adding Baffle impact database performance? It's a pretty good question.
Yeah, that's a pretty common question. And the answer that nobody loves to hear is it depends. And you can think about just how you do it. Like if you have a huge database and you encrypt the entire thing, that's obviously going to be one benchmark. But if you only encrypt a few sensitive columns, that's another thing. And the way Baffle works is when it sees the query, if it's on unencrypted data, it'll just pass it right through. And so it have a negligible effect as far as that goes. The other factor is our architecture and the fact that it's a container, right? So you can say you have a massive 24 core database. You could start out with one Baffle container of like say 2 or 4 cores and just scale it up horizontally through Kubernetes or ECS or however you want to do it as you need to for performance. So there's lots of different ways to handle that.
Awesome. So I know we're running out of time, but it looks like we got one other question. I think it's a little bit tongue in cheek. So someone asked the question, Baffle talks about real queryable encryption. Does that mean that there's such a thing as fake queryable encryption? Like what do you mean? Why do you use the term real?
Yeah, so there's another database provider out there that calls their database queryable encryption, and they're just talking about the direct match version, where if you want to get the credit card number, you get the credit card number. But if you try to do any database side processing, you still get the error. So that's why Baffle calls it real queryable encryption.
Yeah, it's fair. I mean, I think when you explained it to me, it was that you're so limited with the other vendors' queries that it's almost. There's some use, but it's really not. It really can't do what an analyst, for example, or even someone who is a privileged database administrator be able to do with database queries.
Right.
All right. So with that, let me turn it over to Hormaz to do the final housekeeping. And
Okay. Well, thank you everybody for joining us and making this interactive. I really appreciate it and really enjoyed the conversations. We will be sending a recording link over to you as well. And of course, do feel free to share this with your friends or colleagues that you think might also find it helpful. With that, I'd like to thank all of you for joining us. I'd like to thank our speakers, John, Billy, and Sushant, for joining us as well. Have a good day, everybody. Goodbye.